Asbin from S.D.V Academy. Today we will learn about Rolle's theorem, LEGRENGE'S mean value theorem, Cauchy's mean value theorem, Taylor theorem and Maclaurin's series. Okay, the Rolle's theorem states that if a function f of x is continuous in the closed interval a comma b, derivable in the open interval a comma b, and f of a is equals to f of b, then there exists at least one value of x, say c in ab, so that f dash of c is equals to 0. Okay, this is the continuous function. Consider this is the continuous function. I will show another example of this is discontinuous function. For some of you have the doubt that what is the continuous and what is the discontinuous function. The graph will come in this form. Okay, this is continuous function, and for discontinuous function the graph come in this form. Okay, this is the graph come, this is discontinuous function. Okay, this is the graph of this function. Okay, now here this is the value of a, this is the value of a, and this is the value of b, and this is f of a is equals to f of b, and this is the tangent drawn towards this. Okay, tangent drawn, this is x equals to c, and this tangent is parallel to this axis, x-axis. Okay, this tangent is parallel to x-axis. Okay, now this is also another graph. This is the value of a, this is the value of b, and this is the value of c. Okay, this is the value of a and this value of c, and this is x equals to c. So this is the tangent drawn, this is the tangent drawn, x equals to c towards the x-axis. This is parallel to x-axis. Okay, parallel to x-axis. This is discontinuous function. This is another example of a discontinuous function graph. Okay, this is also a discontinuous function graph. The lines will comes in this form. This is another example. Okay, now geometrical interpretation of a function f of x is a continuous function in the closed interval. This is the closed interval, and where f of a is equals to f of b, then there exists at least a point between a and b, that is in the open interval a to b, say x equals to c, so that the tangent is parallel to x-axis at a point x equals to c. I have shown you the tangent. Okay, this is the graph and this is the tangent drawn to the x-axis. Every polynomial is continuous function. Every polynomial is continuous function of x for every value of x. Okay, every polynomial is continuous function. If f and g are both are continuous function, then f plus g, f into g, f divided by g, division, addition, multiplication, division are also a continuous function. If a function is derivable at any point of the interval, it must be continuous at that point. Derivability or continuity. If it is derivability, then it must be continuous. It should be continuous, but every continuous function need not be derivable. Okay, derivable means that implies continuous, but continuous need not be derivable. Okay, if you prove it is continuous means it is need not be derivable. Sometimes it will be derivable, sometimes it will be continuous. Okay, now this is the example problem. Verify Rolle's theorem for the function sin x by e power x in 0 comma x. Okay, now sin x and e power x, this is the graph of sin x, this is the graph of sin x, this is the continuous graph of sin x, and this is the graph of e power x. This is also continuous, this graph is also continuous, this graph is also continuous. For you to show continuous graph. Okay, now sin x by e power x is also continuous function for all values of x in 0 to pi. It is also a continuous function for all values of x. Sin x by x, then f dash of x, we have to check the derivability. So what is the derivation of u by x? U d by dx of v minus, the formula is d by dx of u by v is u d by dx of v minus v d by dx of u by v square. Okay, this is the formula used here. E power x, what is the differentiation of this cos x minus sin x into differentiation of e power x by e power 2x v square e power 2x. That implies take the common e power x. What the value here becomes? Take e power x common, so cos x minus sin x by e power 2x. So here 1x gets cancelled out, so the remaining value cos x minus sin x by e power x, where e power x is not equal to 0, which exists for all values of x. This value exists for all value of x. Now f of x is derivable in 0 to pi. Now we have to check the third condition is f of a is equals to f of b. Then what is the value? F dash of c is equals to 0. Now we have to check this condition here. F of 0 is equals to 0. F of pi, f of x satisfy all condition of Rolle's theorem. There exists at least one value of x, say in c, in 0 to pi, such that f dash of c is equals to 0. Means f dash of c is equals to sin c minus cos c by e power c. This is the value of c. Cos c minus sin c, when you take towards opposite sides, gives the value 0. Sin c minus cos c, sin c minus cos c is equals to 0. That equals cos c minus sin c, that is equals to c value is pi by 4. C value is pi by 4. This pi by 4 lie between 0 to pi. So hence Rolle's theorem is verified. Okay, now comes to the next topic, Lagrange's mean value theorem. In this, if a function f of x is continuous in the closed interval a to b, derivable in the closed interval a to b, and then there exists at least one value of x, say in c, such that f of b minus f of a by b minus a is equals to f dash of c. Okay, now this is the graphical representation of Lagrange's mean value theorem. Okay, now consider this is point A, this is the point B, this is the point C. Okay, now this is the value of A, f of B minus f of C. This is the value of B minus A. B minus A value is this. F of B minus f of A. F of B minus f of A value is this. And this is the tangent drawn. Okay, f of c is the tangent drawn. Geometrical interpretation, f dash of c is the slope of the curve f of x at c. F of b minus f of a, let b and c, this is the value of b and c, is f of b minus f of a, and this is the value of a and b. Okay, this is the triangle from the triangle ABC. Okay, this is the triangle ABC. This is the value of AB and this is the value of BC. So tan theta is equals to f of B minus f of A by B minus A. Slope of the tangent to the curve at a point C is equals to slope of the chord. Means this is the slope of the tangent to the curve at a point C is equals to slope of the curve. Now this is the alternating form of Lagrange's mean value theorem. In the alternating form, in the place of A, you have to put A, and in the place of B, you have to put A plus H. Okay, this is the alternating form of Lagrange's theorem. If a function f of x is continuous in the closed interval A and A plus H, derivable in the open interval A and A plus H, then there exists at least one value of theta. This is the angle lying between 0 and 1, such that f of a plus h minus f of a by h is equals to f dash of a plus theta h, or f of a plus h, put this value here and multiply this value towards this, means f of a plus h, okay, minus f of a, and multiply this value, gives the value h into f dash of a plus theta h. And when this value goes towards RHS, what this value becomes? F of a plus h is equals to f of a plus h into f dash of a plus theta h. Okay, this is the value which has been formed. Now test whether the Lagrange's mean value theorem holds for f of x is equals to x minus x cube in minus 2 comma 1. This is the value of a and b. So this is the value of a and this is the value of b. And if so, approximate value of c. What is the value of c? We have to find it out. This is the value of a is minus 2, and f of minus 2 gives the value 6. Substitute in this value minus 2, minus of minus 2. What this value becomes? Minus 8. gives the value minus 2 plus 8 is equals to 6. This is the value of 6. Put the value of b, minus of 1 cube gives the value 1 minus 1 gives the value 0 here. So this is the value of 0. Now f of b minus a, 0 minus 6 by 1 minus of minus 2 gives the value 6 by 1 plus 2 gives the value 3. 6 by 3 gives 2 minus 6. Minus 6 gives the value minus 2. Now what is the value of f dash of x 1 minus 3x square? F dash of c gives the 1 minus 3c square. So substitute this value here. So what this value becomes? Minus 2 into 1 minus 3c square. So minus 2 minus 1 minus 3c square. So minus 3 is equals to minus 3c square. C square is equals to 1. What is the value of c? Plus or minus 1. Okay, plus or minus 1. This is the value of c. Mean value theorem holds for the function. Okay, my plus of minus 1. This value lies between minus 2 and 1. So this is the mean value theorem holds here. Okay, now comes to the concept of Cauchy's mean value theorem. This is Cauchy's mean value theorem. If two functions f of x and g of x, here we have to consider two functions f of x and g of x. Consider in the closed interval a comma b, where a is less than or equals to x is less than or equals to b, and derivable in the open interval a to b, and g of x is not equals to 0. Such for all value of x in a comma b, g of x should not be equals to 0 here. Then there exists at least one value of x, say c, in a b, so that f of b minus f of a by g of b minus g of a is equals to f dash of c by g dash of c. We have to integrate these two values. Okay, now let us take an example problem so that you can understand this concept clearly. Okay, this is the value of f of x given x square plus 2, and g of x has been given as x cube minus 1 in 1 comma 2. If so, find the value of c. So f of a value is x square plus 2 and f dash of x value is 2x. G of x value is x cube minus 1 and g dash of x is 3x square. Okay, we have to find also the value of a and b. Now f of a is equals to, put the value of 1 plus 2 is equals to 3. F of b value is 2 square 4 plus 2 is gives the value 6. Okay, g of a value is 1 minus 1 gives the value 0. G of b value is 8 minus 1 gives the value 7. So substitute all these values in the formula. What you will get here? F of b minus f of a by g of b minus g of a gives the value f dash of c, g dash of c. Means here 6 minus 3, 7 minus 0. 6 minus 3, 7 minus 0 is equals to, substitute it in this value. C means 2c, and g dash of 3c square. So 3c square 2c. C is equals to 14 by 9. This is the required answer which has been formed. So C lies between 1 and 2. So this is the Cauchy's mean value theorem problem. Now comes to next concept, Taylor's theorem. Taylor's theorem with Lagrange's form of remainder. If a function f of x is such that f of x, f dash of x, f double dash of x, and so on, f n minus 1 of x are continuous function in the closed interval. Okay, for large values, continuous function in the closed interval, this a is less than or equals to x is less than or equals to a plus h, then f power n, f nth order, this is nth order, exists in the open interval a is less than x is less than a plus h, then there exists at least one number 0 theta, this is the value of theta between 0 and 1, such that f of a plus h is equals to f of a plus h into f dash of a, h square by 2 factorial f double dash of a, h cube by 3 factorial f triple dash of a, plus and so on, h power n minus 1 by n minus 1 factorial f power n minus 1 into a, f h power n by n factorial f power n a plus theta h. Okay, and this is alternating form of Lagrange's mean value theorem. In the place of a plus h, you have to put a b. F of b is equals to f of a plus b minus a. In the place of h, b minus a gives the value h is equals to b minus a. In the place of h, b minus a whole square, b minus a whole cube, and so on. Okay, now comes to the Maclaurin series with the Lagrange's form of reminder. Now in the place of a, put the value 0, and in the place of x h, put the value x here in the above formula. So in the place of a, f of x is equals to f of 0 x into f dash of 0 x square by 2 factorial f double dash of 0 and so on. This is the Maclaurin form of a reminder. Now Taylor theorem with Cauchy's form of reminder. With the Cauchy's form of reminder, what we have here, if a function f of x be the such that f of x, f dash of x, f double dash of x, f power n of x are continuous in the closed interval a is less than or equal to x is less than or equal to a plus h, then f, this is also nth order. So exists in the open interval a is less than x is less than or equals to a plus h. Then there exists at least one number theta between 0 and 1 such that f of a plus h is equals to f of a plus h into f dash of a plus and so on, h square by 2 factorial f double dash of a plus and so on. Okay, now here put the value of a is equals to 0 in the above theorem and h is equals to x. Okay, now what you will get here, f of x is equals to f of 0 x into f dash of 0 x square by 2 factorial f double dash of 0 and so on. These are the values of Maclaurin theorem by Cauchy's form of reminder. Okay, now comes to the Taylor series. F of a plus h is equals to f of a plus h into f dash of a plus h square by 2 factorial f double dash of a plus so on f h power n by n factorial f in dash of e. Okay, now in this put the value of 0 and in the put a is equals to 0, h is equals to x. So what you will get, f of x, f of 0 x into f dash of 0 x square by 2 factorial f. Example, tan inverse x in the form of Maclaurin theorem. This is Maclaurin theorem. Okay, in Maclaurin theorem what you have to put, in the place of a you have to put 0, in the place of h you have to put x, in the place of h you have to put x. Now what is the value of f of x? Tan inverse x. So f of 0 is equals to tan inverse of 0 gives the value 0. F dash of x 1 by 1 plus x square. F of 0 gives the value 1. F double dash of x minus 2 x by 1 plus x square whole square. F double dash of 0 gives the value 2. F triple dash of x 6x square minus 2 by 1 plus x square whole cube. F triple dash of 0 gives the value 0. Now f4 dash of 0 gives the value, sorry, this is the value of 0 and this is the value of 2 which has been formed here. So 0 into something is 0 and this is minus 2, and 24 minus 24x cube, this is also value of 0, and f5 dash is gives the value 24. Okay, now substituting these values in the Maclaurin series, so what will get the value here, f of 0 plus f dash of f of 0 plus x into f dash of 0 x square by 2 factorial f double dash of 0 gives the value tan inverse value x minus x cube by 3 plus x power 5 by 5 and so on. Expand log of cos x plus h in the form of h by the Taylor theorem. F of x plus h is equals to log of cos x plus h. We have to use here Taylor theorem. H is equals to 0, f of x is equals to log of cos x, f dash of x sin x by cos x minus tan x, f double dash of x secant square x, f triple dash of x minus cos secant x into tan x minus 2 secant square x into tan x. Substituting these values in the Taylor series gives the value f of x plus h is equals to f of x plus h into f dash of x, h square by 2 factorial f double dash of x and so on. Okay, now this value gives you log of cos x plus h gives the value log cos x plus h minus tan x h square by 2 factorial minus secant square x h cube by 3 factorial minus 2 secant square x tan x. Cos log of cos x plus h gives the value log cos x minus h into tan x minus h square 2 factorial sin square x minus h cube 3 sin square tan x. Okay, this is the required answer which has been formed here. Please like, share and subscribe. If you have any kinds of videos, please comment me in the comment section, and thank you.